Our next topic is the EMF equation of a DC generator. So as the armature rotates, a voltage is generated in its coils. In the case of a generator, the EMF of rotation is called the generated EMF or armature EMF and is denoted as EG. So here is the formula for the generated EMF of a generator. EG will be equal to P Z flux multiplied by the N divided by 60A, where your P is the number of poles of the machine. So this number of poles will be even numbers, north-south, north-south. So flux or the symbol Phi, flux per pole in Weber. So we have here a conversion that if the flux is given in Maxwell's or line of flux, 1 Weber is equal to 1 times 10 raised to 8 Maxwells. Or lines of flux. Or lines of flux. Z is the total number of armature conductors. Total number of armature conductors. So we have one coil in your first topic dun sa binigay ko. So one coil is equal to 2 conductors. So malagipyo dijay figure nga kastoy. So this is one conductor and other conductor. So one coil is equivalent to 2 conductors. N is the speed of armature in revolution per minute. So RPM in speed. A is the number of parallel paths in the armature. So we have two types of parallel paths, di ba? It can be a lap winding or a wave winding. The parallel paths for lap winding, AL is equal to MP. M is the multiplicity and P is the number of poles. While in wave, A is equal to 2M. M is again multiplicity. Your multiplicity can be a simplex. So for simplex, M is equal to 1. Duplex, M is equal to 2. Triplex, 3, and so on and so forth. Or this one is Zphon. Tamno na alis to yung malagip. Zphon divided by 60A. So, unit is in volts. From this equation, EG is equal to P, Z, flux N over 60A, we can see that EG is directly proportional to your speed. So, as the speed of the generator increases, its generated EMF is also increases. The flux in the generator is also directly proportional to the generated voltage. So, as the flux increases, the generated voltage also increases. we have an example here. This is from the book Teraha. A 4-pole generator having wave-wound armature winding has 51 slots, each slot containing 20 conductors. What will be the voltage generated in the machine when driven at 1,500 revolutions per minute, assuming the flux per pole to be 7 milliweber? First, we will list all the given parameters and then solve. So, given, we have here, number of pole is 4, and our parallel path is wave, AW, so that is 2M. Hindi niya in-state kung simplex or duplex, so we will consider it as simplex. So, AW will be equal to 2. 2 times 1. Next, we have conductors. So, there are 51 slots in a generator. So, the total number of conductors will be the 51 slots multiplied by 20 conductors. And the flux per pole is equal to 7 milliweber or 7 times 10 raised to negative 3 Weber. Next one is the speed. 1,500 RPM. So our formula in generated voltage EG is equal to Ziphon divided by 60A. So EG will be equal to 51 times 20 times number of pole 4 flux 7 times 10 raised to negative 3, and N is 1,500 divided by 60 times 2. EG will be equal to 357 volts. So, yung binigay kong PDF, yung number 1, is 178.5. So, that is wrong. Ito yung correct, 357 volts. Example number 2. An 8-pole DC generator has 500 armature conductors and a useful flux of 0.05 Weber per pole. What will be the EMF generated if it is lap connected and runs at 1,200 RPM? What must be the speed at which it is to be driven produce the same EMF if it is wave wound? So, given, we have a number of pole 8 and has total conductors, armature conductors, to be 500. So, Z 500 conductors. Useful flux equal to 0.05 Weber. Required, what will be the generated EMF if it is lap connected? Lap winding. So AL is equal to MP equal to 1 times 8. So 8 parallel paths. And runs at 1200 RPM. So N is equal to 1200 RPM. And then the second required is what must be the speed at which it is to be driven, produce the same EMF if it is wave wound. So this one is in lap connected, and we are required to get the speed at wave connected. If it is wave wound, so the speed at A is equal to wave 2M. Kunana jay the same EMF. So the EMF here at lap that we will be calculating is the same EMF at wave. So what will be its speed? Okay? So first we will solve the generated EMF when it is lap connected. So EG is equal to Ziphon divided by 60A equal to 500 times 8 times 0.05 multiplied by speed at lap, so 1200 divided by 60A. Our A here is lap, so 8. So EG will be equal to 500 times 8 times 0.05 times 500 volts. So what will be the speed if it is wave connected and the same EMF? So at wave, N is equal to what? So same formula, EG is equal to Ziphon divided by 60A. So equal to ditoy 500 equal to 500 times 8 times 0.05, and the speed is unknown, divided by 60. So our A here at wave winding is equal to 2M 2 times 2. So speed is equal to it is equal to 300 RPM. Therefore, with wave winding, it must be driven at 300 revolutions per minute to generate 500 volts. So example number 3. A DC shunt generator has an induced voltage on open circuit of 127 volts. When the machine is on load, the terminal voltage is 120 volts. Find the load current if the field circuit resistance is 15 ohms and the armature resistance is 0.02 ohm. So ignore armature reaction. In this figure, first figure, the output voltage on no load means there is no connected load in this terminal. So it has a terminal voltage of 127 volts at field resistance of 15 ohms. So this is 15 ohms. And inside this generator, there is an armature resistance of 0.02 ohms. Same here. So we have 15 ohms and 0.02 ohms. When the generator is loaded, its new terminal voltage is 127 volts. So what will be the load current when the generator is loaded? So here, since this is not loaded, the load current here is simply 0 kasi this is an open circuit. So from our formula, DC shunt EG is equal to terminal voltage plus IARA, where our IA is equal to ISH plus IL. So since at no load, this is open, so IL is 0. Therefore, our IA is equal to ISH. The generated voltage at open or no load is equal to 127 plus ISH. Paano natin makukompute yung ISH? So, ISH is equal to terminal voltage divided by RSH. 127 divided by 15. So, that is equal to 8.4667 ampere. So, 8.4667 times our RA is 0.02. Our generated voltage will be equal to 127.167 volts. This is on no load. If we assume that EG is not changed or unaltered, we will have from our formula EG is equal to VT plus IARA. So our EG is unaltered. We have 127.167 equal to our new terminal voltage 120 plus our IA is equal to ISH plus IL, where our ISH is 120 divided by 8. So that is 120 divided by 8, 15 amperes. So our IA is 15 plus IL times 0.02. So the value of our IL will be equal to 343.35 amperes. Next problem is example 26.11. So, an 8-pole DC shunt generator with 778 wave-connected armature conductors and running at 500 RPM supplies a load of 12.5 ohm resistance at terminal voltage. This is 250. That is 250. Correction dun sa PDF. So, the armature resistance is 0.24 ohm and the field resistance is 250 ohm. Find the armature current, the induced EMF, and the flux per pole. So, from our circuit diagram of a DC shunt, let's draw. This is your generator. And it is connected to a load 12.5 ohm. Our shunt resistance is 250 ohm, or the field, padpada lang. Inside the generator, there is an armature current, armature resistance 0.24. And this generator is driven by a speed of N is equal to 500 RPM. At the output voltage, we have 250 volts VT. So, what will be the value of your armature current, IA, induced EMF, EG, and flux per pole? We have two working equations here. For shunt generator, we have EG is equal to VT plus IARA. And our EG is equal to Ziphon divided by 60A. Since our our RA is given, our VT is given, and also we can solve IA, we can first identify the value of your EG. So, we will solve first what is the value of your IA. IA is equal to ISH plus IL, where ISH is equal to terminal voltage divided by RSH, and your IL here, this is your IL, this is your ISH, and the direction of your IA. So, IL is equal to, since terminal voltage is given and also the resistance is given, we can solve IL using Ohm's law. So, IL is equal to terminal voltage divided by the load resistance. So, ISH is equal to 250 divided by 250. We have 1 ampere. And IL is 250 divided by 12.5. So, we have 20 amperes. Armature current now will be equal to 1 plus 20. So, we have an armature current 21 amperes. EG is equal to our terminal voltage, which is 250 volts plus 21 ampere times 0.24 armature resistance. So, EG will be equal to 255.04 volts. Na-solve na pala natin yung isang required, yung IA. So, dalawa na pala yung na-solve natin. We have your IA and EG. So, the last one is the flux per pole. From this formula, we can formulate the equation of flux. So, flux is equal to EG divided by 60A. EG times 60A. So, flux is equal to EG 60A divided by JPN. So, flux is equal to 255.04 times 60 times A. What is our A? Since this is a wave, AW is equal to new wave cut 2M. So, it's equal to 2. Times 2 all over conductor is 778 times number of pole we have 8 times our speed is 500. So the flux per pole now will be equal to times 8 times 500. 9.834 milliweber. So we have two conditions at N1 equal to where is that? 1,200 and it drops at 1,000 RPM. So at N1 we have here given N1 is equal to 1,200 RPM at load current equal to 200 amperes. So our separately excited DC generator supplies a load and it has a load current 200 amperes at a terminal voltage equal to 125 volts. And then at condition 2 we have speed N2 equal to 1,000 RPM. And the field current is reduced to 80%. So, in a DC shunt, or separately excited, or any kind of, any types of generators, we said earlier that generated EMF is directly proportional to flux, di ba? And this flux is associated with current, the current of the generator. If here at condition 1 we have a field current, hindi siya nag-increase or nag-decrease, so we have a flux here. And at condition 2, we have our flux 2 is reduced to 80%. So we have flux 2 reduced to 80% of flux 1. So this is flux 1. Armature resistance. So RA is equal to 0.04 ohms. And the brush drop is 2 volts. Now, we will draw the separately excited DC generator. So, this is our field winding. So, may flux tayo dito. This is our external source. So, we have IF here, field current. This is field winding. And this is our generator. We have a constant resistance. So, hindi niya sinabi. So, this is load. And a terminal voltage equal to 125 volts. And then we have IL equal to 200 amperes. From here, we can solve this is at N1. So, 1,200 RPM. We can solve our EG1 equal to terminal voltage plus IARA plus the drop in the brush. So, we have here terminal voltage 125 plus our IA is equal to IL kasi they are connected in series. Nandito yung IA natin. So, 200 times RA is 0.04 plus 2. So, terminal voltage equal to 135 volts. From our formula a while ago, where EG is equal to Ziphon divided by 60A, from here we can see that your generated EMF is directly proportional to the flux and the speed. Okay? So, as the speed increases, constant yung flux, the generated EMF is also increases. Same the other way around. So, from here, bumaba yung flux natin, bumaba din yung speed. So, we will expect your generated EMF to be decreased also. Okay? So, we can equate condition 1 and condition 2. And condition 2. So, we have a condition 1, EG1 is directly proportional to flux 1 and 1, and EG2 directly proportional to flux 2 and 2. So, EG1 over EG2 is equal to flux 1 and 1 divided by flux 2 and 2. We can now solve your EG2. So, EG1 times flux 2 and 2 equal to EG2 flux 1 and 1. Solving for EG2, it is equal to EG1 flux 2 and 2 divided by flux 1 and 1. EG1 is 135 times flux 2 is 0.8 of flux 1 N2, 1000 divided by flux 1, N1 is 1200 is equal to 90 volts. Please practice to solve the other problems, and you can get any solving problems in the internet and then you try to solve them. If you cannot understand, you can ask me, you can direct message me, and we will try to solve that one. Okay?